Hello, everyone. Welcome. We are going to look at the basics of trigonometry. Now, trigonometry, the word itself, okay, if you break it up into its root words, you have trigon, which represents a triangle, three-sided figure. Then you have metry, which represents measure. So essentially, trigonometry is the study of the measure of the relationships between the side lengths of a triangle and its angles. So it's basically triangle measurements or the measurements of triangles. Okay, guys, that's what trigonometry is about. Now, there are three basic functions which you guys are very familiar with from maybe your geometry classes, which we use when it comes to trigonometry. We've got the sine, shortened for S-I-N, not sin, it's sine. Then we've got the cosine, okay, which is shortened to COS, cosine. And then we've got tangent. You also have their inverses as well, guys. So tangent, the shortened form for this one is TAN. Now, there's also the inverses. And if we look at the inverses, we'll talk about them in a little bit. We're looking at a total of 6 trig. By the way, when you talk about trigonometry, you don't even have to say the entire term. You could just shorten it to trig, okay? So the 6 trig functions, all right? So again, we got the 3 basics, sine, cosine, tangent. And then there are inverses, the inverse of sine, the inverse of cosine, the inverse of tangent would make up the other 3. So when you put all of them together, you'll end up with 6 trig functions, guys. Now, in order to better understand this, we are going to head back to geometry class, okay? Now, back in geometry class, you guys encountered a right triangle. Now, a right triangle, remember, has a right angle. Directly across from the right angle, you have this side right here called the hypotenuse. Hypotenuse, okay? And so you have your hypotenuse there. I think I need to erase that because I just ran off my screen here, guys. So let me go ahead and erase it and try writing that again. Let me write it there. Hypotenuse. All right, there we go. So the first thing you need to do when it comes to a right triangle is to identify the hypotenuse. The other 2 sides, okay, are referred to as the legs of the right triangle, okay? So now, if you've got this leg right here and you've got this leg over here, the question is, how do you differentiate the legs, okay? That's where the angles come in. Depending on where the angle, which angle is in discussion. By the way, these angles here, angle theta, this symbol here represents theta, okay? These are some of the more commonly used symbols we use to represent angles. We also use theta, we use alpha as well. That's another basic one we use to represent angles, to name the angles. And there's one last one, guys, I'm going to mention here, which we'll use very frequently in this class, and that is beta, okay? So these are the 3 common symbols, Greek symbols we're going to use to represent the angles. So going back to our right triangle here. So depending on which angle that's in question, we've got angle theta right here. So if we're talking about angle theta, this side over here is touching angle theta. So this leg right here is touching angle theta. So we're going to call it the adjacent side. And adjacent means this, guys. Next to or touching. That's what adjacent means. So if it's not the hypotenuse that's touching the angle, the other side that's touching the angle, we refer to it as the adjacent side. All right, guys, now we're gonna move on to this side right here, which is not touching the angle. And this side that is not touching the angle, we refer to it as the opposite side, as in it's away from the angle. It's opposite the angle in question, okay? That's the opposite side. So guys, you have to understand the basics. You have to be able to know which side is opposite, which side is adjacent. So of course, everybody knows how to figure out which one is hypotenuse and so forth and so on. Now, we've got some abbreviations, okay? So before we get into the actual trig functions, we're gonna use the abbreviations. Adjacent for ADJ, and then opposite, we're going to use OPP. OPP, there was a song like that way back when. Get down with OPP and you know who. Okay, all right. That's besides the point. Anyways, the hypotenuse is HYP. We're going to need those later on, guys. Okay, so heading back to this, guys, when we are looking at trigonometry, sine, cosine, tangent, basically it is a measurement of the ratio of the two sides of a right triangle. So if we're talking about angle theta here, and we're looking for the sine of angle theta, we're looking at a ratio between those two sides, okay, of theta. Now, before I get ahead of myself here, let me go ahead and slow down a little bit. I'm going too far, okay? So one of the things I want to address is this, guys. You will encounter many of these right triangles where you are missing a side. And of course, your first step would be to find that missing side. For example, if you have this right triangle here, this side is 5. This side right here is 12. And you're missing the hypotenuse, okay? You're missing the hypotenuse. For a lack of a better variable, I'm just gonna go ahead and use C right here. You're missing the hypotenuse, okay? So when it comes to these type of problems right here, if you are given a right triangle where you are given 2 legs and you're missing the third side of the triangle, so you're given 2 sides and missing the third side, what you have to do is to calculate the third side. And one of the most common formulas we learn about in geometry to calculate the missing side of a right triangle given 2 sides is the Pythagorean theorem. Pythagorean theorem, okay? So the Pythagorean theorem, all right, let's see here, let's write it down. Pythagorean theorem. All right, guys, that's what we're going to use in order to calculate that missing side of the right triangle. And everybody knows the Pythagorean theorem. And of course, that is a squared plus b squared is equal to, go ahead, say it, c squared. All right, guys. So remember, C represents the hypotenuse, and the hypotenuse is the side directly across from the right angle. So that's the side we're looking for. And then the other 2 sides represents the legs of the triangle. So you have one leg here and you have another leg here. These 2 sides here, they represent A and B. It doesn't really matter which one is A, which one is B, but typically you want to make the shorter leg A, the longer leg B. So if that is the case, then we would substitute 5n for A, 12n for B, and then go ahead and calculate the value of C. Well, with some quick calculation, 5 squared is 25, 12 squared is 144. If you add them together, that's going to give you 169. So if you have 169 equals to C squared, to calculate the value of C, you want to take the square root of 169. And so this will equal out to 13. So guys, that is some basic facts about the right triangle. Given 2 sides of a right triangle, to find the third one, you go ahead and use the Pythagorean theorem to calculate the missing side. Okay, I'm gonna do one more like this because I wanna make sure you guys understand that, because we're going to be dealing with many right triangles, and you have to be able to quickly come up with those missing sides, okay? And guys, be careful when it comes to Math Excel for school. Remember, Math Excel doesn't like the decimals unless they specifically tell you to use a decimal as part of your solution. You need to either use a fraction or you can use a simplified radical. Simplified fraction, simplified radical, unless they tell you otherwise, okay? So I'm gonna do one more right triangle. So let me see here. Let's do this one right here, guys. Ew. All right, I'm gonna make this one the hypotenuse. Let me see, let me make the hypotenuse 10, okay? And I'm gonna make this leg right here 8. So obviously this leg is missing, this side is missing. So this side right here that's missing, I'm just gonna go ahead and call it A, okay? So our job now is to go ahead and find that missing side. So we're gonna go back to the Pythagorean Theorem. Once again, A squared plus B squared equals to C squared. And we're going to go ahead and calculate the length of the missing side. So once again, here's our right angle. The side that is directly from the right angle is the hypotenuse, and that always represents your C value. So you've identified your C value. So let's go ahead and substitute the 10 in for C, okay? And so now we're gonna go ahead and plug in the information for the other two sides. Well, this one, I'm calling it A, it's missing, so we're just gonna go ahead and fill that in there. But this side right here has a length of 8 units, so we're gonna go ahead and plug in 8 for B and square it. So now let's work it out to calculate the value of A. So 8 squared is 64, 10 squared is 100. You subtract 64 from both sides, and so the result ends up being A squared is equal to 36, okay? So remember, this cancels out here, guys. Now remember, you're looking for A. You're not just looking for A squared. You're looking for A. And A squared, remember, guys, wouldn't make any sense within the context of this problem because these numbers are 8 and 10. So you want an answer, especially since it's a leg, you want an answer that's less than 10. So make sure you use that good old-fashioned common sense. So you want to take the square root of both sides in order to calculate the value of A. So you arrive at a value of 6 units. So the A value is 6, okay? Questions? All right, so I'm gonna keep going, guys. Now, I'm gonna erase this part right here. So that is one of the first things you have to be able to do, guys. Are you able to, given a right triangle and two sides and one missing side, are you able to figure out the third side? All right, so now, guys, let's get into the trigonometry part of this. All right, so theta. Let's talk about theta and the 3 basic trig ratios, okay, guys? So I am going to start with sine. Now, sine is defined as the sine of an angle, okay? And we're using angle theta, is defined as the opposite side, the side away from the angle, over the length of the hypotenuse. So once again, sine is defined as the opposite side away from the angle over the length of the hypotenuse. So the length of the opposite sides over the length of the hypotenuse. You can shorten that, abbreviate it to opposite over hypotenuse. Now, let's move on to cosine. Cosine of theta is defined as the adjacent, the length of the adjacent side over the length of the hypotenuse. All right, guys. So when we abbreviate that, it's going to become ADJ over HYP, as in the abbreviated version of adjacent, the abbreviated version of hypotenuse, okay? So adjacent over hypotenuse. And then the third one we're looking at is tangent of theta. The ratio for the tangent of theta is going to be the opposite over the opposite side over the adjacent side, guys. So when we abbreviate this, it's going to be opposite over adjacent. So just like this, guys. All right. Now, those are your three basic trig identities. Sine theta, which is the opposite over the hypotenuse. Cosine theta, which is the adjacent over the hypotenuse. And then tangent theta, which is the opposite over the adjacent, guys. Now, one of the things you guys learn in geometry is this. You guys learn about a mnemonic device, which you can use to help you remember the trig identities, okay, the trig functions. So let me write it down. Okay, so ha, toa. Sometimes I like to refer to it as sakatao, okay, because it's got a nice ring to it. Now, SOHCAHTOA helps you to remember the three basic trig identities and eventually the inverses as well. So you've got sine. And so sine will stand for, right there, let me go ahead and do this, will stand for the opposite, that's the O, over hypotenuse, that's the H. Then you've got C, which stands for cosine, and that would represent adjacent for the A over hypotenuse. And then finally, you have the T, which represents tangent, and tangent means right here, the opposite for O over the adjacent for A, okay? So that's how, guys, the mnemonic device is going to help you remember which one is cosine, which one is sine, which one is tangent. All right, everybody. So we're going to start with a basic triangle, right triangle, and we're going to calculate some of these ratios. Okay, so here's a basic right triangle, and I'm going to give you this angle right here, which is theta. So this length is 12. This length right here is 5. I think that should have been a little shorter right here. And this length right here, we're going to call it 13. It's the last triangle I worked out with you guys, okay? So I need you to find the ratio for the sine of theta, cosine of theta, as well as the tangent of theta. I want you to find the ratios. So guys, personally, the first thing I would do until you become comfortable with this is to go ahead and identify the adjacent side and the opposite. I mean, I think everybody is okay with the hypotenuse, the side directly across from the right angle, okay? So if you're okay with that, the next thing to do is to identify which side is opposite, which side is adjacent. So here's your angle theta right here. The side that is touching angle theta is right there. So therefore, the 12 would be the adjacent side. And then this angle right here, I mean, this side right here is away from the angle. So this would represent your opposite side. So now that you figured it out, okay, which one is opposite, which one is adjacent, it's just a matter of filling in the ratios. So let's find a ratio for sine. Sine theta, sine of the angle would be, remember, that's the opposite over the hypotenuse. So the opposite side is 5. The hypotenuse is 13. So 5 over 13 would be the ratio, guys, the ratio of sine theta. Now, cosine theta, remember, is the adjacent over the hypotenuse. You've already identified your adjacent side, which is 12. And so the hypotenuse length is 13. There you are. And then last but not least, tangent, you've got opposite over adjacent. So the opposite would be 12 over 13. I mean, I'm sorry, Shazam, what did I just write? The opposite over the adjacent. My mind is moving too fast, guys. So the opposite over adjacent for this one would be 5 over 12, the adjacent. And guys, just like that, you figured out the 3 basic trig identities for this particular triangle. All right, so I'm gonna go ahead and move on to the other ones, okay? So let me go ahead and erase some of these. And then let's address the other 3 trig functions. Now the other three trig functions, okay? I'm trying to speak here, people, okay? Represent the inverse of the 3 basic trig functions. So we got the inverse of sine. Now just a little bit of math here if you guys really want to know. The inverse of sine would be 1 over sine, as in you're taking the reciprocal, okay? 1 over sine. So guys, remember, if you're writing sine, sine is over 1. If you're doing the inverse of it, you would flip it. Okay, now I'm gonna do a little bit of math here. So 1 over, sine represents the opposite over the hypotenuse, okay? So essentially we have 1 divided by, the fraction bar represents division, 1 divided by opposite over hypotenuse. If this is getting a bit too much for you guys, it's okay if you don't get it, it's okay. I just want to show you the mathematics behind this, okay? When you're doing division of fractions, you're supposed to keep the first fraction and then multiply by the reciprocal of the second fraction, which becomes hypotenuse over the opposite. So guys, if you multiply this out, you end up with the hypotenuse over the opposite. So guys, the inverse of sine is hypotenuse over opposite, and we refer to this as the, okay, now be careful with this, guys. It is the cosecant. This is the inverse of sine, cosecant. And when we write it out, we write it as CSC, okay? Cosecant when you pronounce it out. So if we're looking at this, the cosecant is going to represent the hypotenuse, the length of the hypotenuse over the opposite. Once again, the cosecant, which is the inverse of sine, would represent the hypotenuse over the opposite. So guys, you notice these two are inverses of each other. You see that? Yeah. All right, everybody. Any questions? All right, let's move on. So I am going to move on to cosine next, and I'm not going to do all that math with you to show you where it's coming from because I've already shown you with sine, so I'm just going to go straight into it for the cosine and the tangent. Now, for the cosine, its inverse, okay, the cosine, hold on a second, there we go. The cosine is going to have an inverse of 1 over cosine, which is going to be basically the reciprocal of this. So that would become hypotenuse over adjacent. And the inverse of cosine is referred to as the secant, guys. And the abbreviation we use for this is SEC, the secant, okay? So the secant is the inverse of cosine. So when we write it out, guys, the secant, in terms of its ratio, the secant would equal to the hypotenuse over the adjacent side. Remember, this is just the inverse of cosine. Look at that right there. You're just flipping this fraction and reciprocating this fraction right there. Okay, guys? So next, I am going to go ahead and move on to tangent. Okay? Now, for the tangent, just like with sine and cosine, hold on a minute. Okay, so just like with sine and cosine, the inverse of tangent is going to be 1 over tangent. So if you're going to reciprocate this, it's going to become adjacent over the opposite. So the tangent, refer to it as the cotangent. And so the cotangent is abbreviated as COT. So the trig ratio for the cotangent then would be the adjacent, remember it's just the inverse, over the opposite. Oh, I forgot to change my color here. Adjacent over the opposite. This represents the cotangent. So guys, here you are, right there, look at that. We're just reciprocating this, that's it. So guys, let me go ahead and recap all of this now that we're done. So the 6 trig functions are sine, okay? Its inverse is cosecant, CSC. Cosine is the next one. Its inverse is secant. Tangent is the third one. Its inverse is cotangent. So there's your 6 trig functions, guys. Any questions? All right, so now I am going to go ahead and clear this out, and we're going to start with a triangle from scratch, okay guys, from scratch. We're going to do a triangle from scratch, and then we're going to figure out all 6 of the trig identities. And I'm going to make it a little bit more complicated because I want to make sure you guys understand, okay? So I might have to do 2 examples, okay? So let's see here. Let me draw my right triangle. All right. And this time I'm actually going to label this, guys. Triangle ABC. So the hypotenuse is located right here, of course, there it is, okay, directly across from that right angle. And this time I am going to make the hypotenuse 3. Side BC, I'm going to make it 1. By the way, guys, if you want to name the sides using 2 letters to name the sides, you can use the lowercase letters to name the sides. So since the hypotenuse is directly across from angle C, okay, we could go ahead and call it lowercase c. And since BC is directly across from A, we could call it small a, lowercase a. And since AC is directly across from B, we could call it lowercase b. So in the case of this problem right here, guys, I'm giving you 2 sides. One side is missing. Ooh, you know what? I just realized it's going to give you some radicals. Maybe you guys are not ready for the radicals yet. So let me give you something a bit more basic than that, because I don't want to get you all caught up in the radicals, because right now I just want you to learn the basics, guys, and then we'll move on to the radicals eventually. All right, so here's one of the common right triangles, okay? One of the most common types of right triangles. So I'm going to see if you guys can figure this one out. I'm going to say this one is 3, and this side here is 5, so we're missing side B. So of course we need to figure out side B. And some of you who are familiar with these type of common right triangles probably already figured out the value of B. But if you didn't, that's okay. We're going to go to the Pythagorean Theorem, and we're going to calculate the value of B. So A is 3 units. We don't know the value of B. And C is 5 units. So we're going to work it out. We get 9 plus B squared is equal to 25. You subtract the 9 from both sides. So this cancels out, leaving you with B squared is equal to 16. Now, guys, why am I writing with red? I guess I love red. I don't know. Okay, so I'm going to take the square root of both sides, so I get B is equal to 4. So, guys, one of the most common right triangles in terms of sides is a 3, 4, 5 right triangle. And you could do repeats of it like 6, 8, 10, or perhaps 9, 12, 15. Those are repeats of it, multiples of the 3, 4, 5. Another very common one, guys, is the 5, 12, 13 right triangle. So it's good to know some of these basic right triangles off the top of your head, okay? So now, guys, I've figured out the missing side, it's 4. So I'm going to calculate the ratios of the 6 trig functions. All right. So here we go, people. Remember, these questions are going to appear in Math Excel. So you will see these type of problems in Math Excel, okay? So we're gonna start off with sine. Oh, I didn't identify which angle, Shazam. Okay, guys, here's the angle theta, okay? Now, I'm also going to do another one too, okay? So sine of theta, the opposite. By the way, if you're still having a hard time figuring out which one is opposite, which one is adjacent, take a moment and label them. Remember, this is theta. The side next to theta is adjacent. So if that's the adjacent side, then this means that this is the opposite side here, okay? So the sine of theta, once you label these, would be the opposite side, which is 3, over the hypotenuse, which is 5. Now we're going to go straight into cosine of theta. Cosine, remember, is defined as the adjacent over the hypotenuse. The length of the adjacent side is 4. The hypotenuse is 5. And then, guys, we're going to move into tangent. And tangent is simply this. Tangent is the opposite side over the adjacent. The opposite side is 3. The adjacent side is 4. So there's your 3 basic trig ratios. So now we're going to go into their inverses. So the inverse of sine is cosecant. So cosecant, remember, is the inverse. It's the reciprocal, okay, of sine. So just take the reciprocal of 3 over 5 and get 5 over 3. Yeah, it's that easy, okay? So cosine, guys, is secant. So you want to go ahead. Remember, it's the reciprocal of cosine. So what's that, my angle measure here? Angle. Okay, so the secant of theta would just be the reciprocal of 4 over 5. So that's 5/4. Likewise, the cotangent of theta would be the reciprocal of tangent. So the reciprocal of 3 over 4 will become 4/3. And just like that, guys, you're done with the 6 trig functions for this particular triangle. All right, so hopefully that made sense. I'm going to do one more like this. And then I think I want to do a little word problem and end it there, guys. So here comes the next one. Now I'm going to go ahead and tackle, okay, I am going to tackle the previous one that I was going to give you. This is A, that is going to be B, and this is C. There's your right angle. Okay, this time around, guys, I am going to give you, let me see here, C is equal to 3, and A is equal to 1. Again, we're going to be looking for side B, it's missing. So we're going to go into the Pythagorean Theorem, A squared plus B squared equals to C squared. Many times, guys, you don't have to really look for the missing sides. They would already give you all 3 sides, so you don't even have to find them, okay? And this time around, guys, listen, not only am I going to do, you know what? Let's put theta here, and let's go ahead and put beta here, okay? So we're going to do it for both beta and theta, so we can see the relationship between the two, okay? So this is the A value. This is the C value right there. We go into the formula, plug it in. 1 squared plus B squared is equal to 3 squared. 3 squared is 9. We subtract 1 from both sides, so you get B squared is equal to 8. All right, guys. Now, do you see why I did not want to do this problem for the last example? This is why. You're going to have to simplify radicals. Shazam, okay? Square root of B squared is B. No decimals, guys, so you have to simplify radical 8. 8 is 4 times 2. 4 is a perfect square. Take the square root of 4. So you get B is equal to 2 radical 2. Okay, I hope you guys got that. So the length of B is going to be 2 radical 2. So now you have that, okay? You can go about finding the trig functions for each of these angles, okay? So let's start off with theta. So the sine of theta, guys, sine of theta is going to be, remember, this is the adjacent because it's touching theta. This is the opposite because it's away from theta, okay? Now, I'm going to do a side-by-side comparison in a minute. So the sine of theta for this one is going to be the opposite, which is 1 over the hypotenuse, 1/3. Cosine of theta is going to be the adjacent, which is 2 radical 2, over the hypotenuse, which is 3. And then tangent of theta is going to be the opposite, which is 1 over 2 radical 2. I'm sorry. Okay, let me see here. Oh, that's good. Yeah, we're good. Now, guys, the reason why I took this little pause here is because here we've got a radical in the denominator. We're not allowed to have radicals in the denominator, so we got to eliminate it. How do we eliminate it? We need to rationalize the denominator, as in get rid of the radical from the denominator. So to rationalize this one, to get rid of the radical from the denominator, let me use a different color here. I am going to multiply both the numerator and denominator by radical 2. And what is my goal? My goal is to eliminate, remember, eliminate the radical from the denominator. So why am I multiplying it by radical 2? Because if I multiply radical 2 and radical 2 together, I get radical 4. Radical 4, guys, square root of 4 is 2. Shazam, I just eliminated the radical from the denominator. Did you guys see that? It's gone. So this simplifies to square root of 2 over 4. And there we go, guys. So that would be the tangent of theta. Now, the thing is, if I were to do the other ones, the same thing is going to happen too. I'm going to have to simplify. Let me see. Do I want to do that? You know what? Let's just keep going, okay? Let's just do it. So let's do the cosecant, and the cosecant would be the reciprocal of this, so it's just going to be 3. All right, the secant would be the reciprocal of 2 radical 2 over 3. So that's going to be 3 over 2 radical 2. Shazam, we're going to have to simplify again, guys. So if you multiply both the numerator and denominator by radical 2, let me work it out for you. Okay, let me use a different color. Multiply by radical 2 in the numerator and denominator. So I'm going to get 3 radical 2 over 2 times 2, which gives me 3 radical 2 over 4. Okay, remember radical 2 times radical 2 gives you radical 4 gives you 2. All right, and then finally, guys, the cotangent, ooh, shazam, we're going to have to simplify radicals again. So the cotangent, let me see here, how am I going to squeeze it in there? All right, I'm going to eliminate this part right here. Let me eliminate this so I could do the cotangent. So here comes the cotangent. The cotangent of theta, I could keep getting to put my theta here, is going to equal to, remember, it's just the inverse of tangent, guys, the inverse of tangent. So earlier we had radical 2 over 4. So if we do the inverse of that, it's going to be 4 over radical 2. But you can't leave the radicals in the denominator. So you multiply the numerator and denominator by radical 2. So this is going to simplify to 4 radical 2 over 2. And what ends up happening, guys? It reduces to simply 2 radical 2. And there we go. That was a whole lot. Shazam. Okay. So I am going to do this. Let me clear this out. I was going to talk about beta. So let me just quickly talk about beta, angle beta, because I need to show you guys something. This was 2 radical 2. This is 1, and that's 3. This is angle beta right there. So in regards to angle beta, guys, okay, the side touching it, the side touching the angle would be the adjacent side. So now the adjacent side moves. The side away from the angle would be the opposite side. You see that? So depending on which angle you're talking about, that changes which side is opposite and which side is adjacent. So if we were to do the quick trig function, sine of theta, its ratio would be, oh, I'm putting theta, that's beta. Sine of beta would be 2 radical 2 over 3. Cosine of beta would be 1 over 3. Tangent of beta would be 2 radical 2 opposite over the adjacent, which is 1. By the way, guys, this simplifies to 2 radical 2. Now, if you want to move on to cosecant, which is the inverse of the sine, so that will give you 3 over 2 radical 2. And then, of course, you would have to simplify this out. And when you simplify it out, it should come out to 3 radical 2 over 4. Now, the secant is the inverse of cosine, so that would just give you 3. And then finally, the cotangent is the inverse of tangent. That would be 1 over 2 radical 2. But again, if you want to simplify this, you can. It would simplify to radical 2 over 4 because we did it previously. So guys, here you are. That's essentially it. Hopefully, you've gotten something out of this basic trigonometric, okay, functions, and it makes sense to you. So I wanted to do a little word problem here, all right? And so I'm looking for an easy one, but I think what I want to do is save it for class, and we'll go ahead and look at the word problem together in class. So I'm going to end the video here, guys, and I will see you on the flip side in class. Bye.